Okay, strap in, everyone. Today's deep dive is, well, a little different.
Different good, I hope.
Oh, it's good. Definitely good. But different. We're tackling this paper, and the title alone.
Yeah, the title's a bit out there.
It's all energy, dummies. Hard to ignore that, right?
Subtlety wasn't the author's goal, I'd say. But hey, it got us talking about it, didn't it?
Exactly. And that's kind of brilliant. So beneath the bold title, there's this question. Could the universe really be that simple? Like, is everything just energy, different forms?
That's the deep dive today. Does it hold up? Let's find out.
And the paper jumps right in. Chapter 1, no messing around. Energy, the true theory of everything.
Straight to the point. Forget all the complex stuff the author's saying. String theory, multiverses, all that. The true answer, it's all energy.
Like a theory of everything, but way shorter.
Physics in a soundbite almost.
Oh.
Modern physics has been on this quest, right? Decades trying to unify the forces. One equation to explain it all.
And this paper's like, nah, too complicated. Here's the real answer.
Kind of refreshing in a way.
So, okay, everything is energy. But what does that even mean? How does it explain all this stuff around us?
Chapter 2 gets into that. The universe is just energy doing stuff. Catchy.
Very direct.
The argument is all the labels we use, matter, particles, forces, distractions, convenient, but just categories at the core, energy-changing states.
So this rock, that tree, me, you, all just energy vibes at different, frequencies or something?
Exactly. The paper proposes, that's it. We see separate things, but it's all one big energy dance, super intricate, that's creating the universe.
Okay, I kind of see how that's unifying, but still abstract. Any examples? Does the paper get specific?
No, it does. Chapter 3, and we knew this was coming. Tesla was right. He just over-explained.
Had to be Tesla, right? The OG energy guy?
The author loves and hates him, it seems. Tesla had the energy insight, but wordy.
So Tesla, right on the big idea, just needed better editing. Kind of like this author, huh? Concise is their thing.
Definitely. But jokes aside, this chapter is where it gets more concrete. Tesla's ideas, energy, frequency, vibration. Paper uses those to explain light, sound, even how matter acts.
All right, getting more applied now. But okay, big mysteries time. Gravity. Does this paper even try to explain that with energy?
Oh, buckle up. Chapter 4. Gravity isn't a force, it's energy inertia. Bold claim right there.
Energy. Inertia. What's that even mean?
Think bowling ball on a trampoline makes a dip, right? Paper says massive objects, planets, stars do that to space-time, but the dip's from energy, inertia.
Inertia meaning what? Resistance?
Yeah, resistance to change. Massive object, massive energy, hates to move. Creates that dip in space-time, paper says. That's what we feel as gravity.
So not a force pulling things in, but more like heavy stuff warping space-time because it's too energy lazy to move.
Oh.
And we fall into those dips.
Precisely. The paper says what we call gravity is us following the curves made by energy inertia.
Mind-blowing, right? Definitely makes you think about gravity differently. But okay, what about the ultimate space-time warper? Black holes. Gotta have an opinion on those.
Chapter 5 does not disappoint. Black holes are fat energy wells, not holes. You see where this is going?
Everything's energy, so black holes got to be energy too, right?
100%. No actual hole, paper says. It's a region where energy inertia is just maxed out. Cosmic traffic jam, so much energy stuck there, creates insane gravity.
So not empty, but super duper full of energy.
That's the claim, and they use that to explain the weird black hole stuff. Event horizons, Hawking radiation, all about energy, according to this paper.
Event horizon, that's the point of no return, right? Once you cross it, even light can't escape.
Exactly. And Hawking radiation, that's the theory that black holes actually leak a tiny bit of energy.
So even with all that energy jammed in, some still leaks out.
Current thinking, yeah. And the paper ties it back nicely, that leaking. It's the insane energy inertia of the black hole. But over, billions of years, it slowly dissipates a bit. Cosmic give and take, even at the edge of oblivion.
Wild. Okay, so black holes aren't just sucking everything in. They're slowly radiating some energy back out, too.
Like a cosmic energy cycle, even in the most extreme places.
Okay, we've done gravity, black holes, all energy so far. But what about the really big mysteries? Dark matter, dark energy, those stumping scientists forever. Does this paper have answers?
Oh, absolutely. Chapter 6, dark matter and dark energy, just more energy inertia. You can guess a theme.
Let me try. It's saying dark matter, dark energy, not actually different things, just more energy inertia, but on a cosmic scale this time.
You got it. dark matter, the invisible stuff holding galaxies together. Paper says maybe it's just huge halos of energy surrounding galaxies.
So not weird unknown particles like physicists are searching for, but energy we can't see.
That's the proposal. And dark energy, even bolder. That's the thing, making the universe expand faster and faster, like some hidden gas pedal.
Yeah, like the universe has a lead foot we haven't found.
Right. So the paper says maybe dark energy is just the inertia of space-time itself on the biggest scale. Remember, massive objects making those energy wells.
Bowling ball on the trampoline, yeah.
Well, paper says on the whole universe level, the energy of space-time itself, it's resisting the pull of gravity inwards. That pushback, that's dark energy.
So no new force, just space-time being space-time. It's energy pushing outward.
Exactly. Another radical simplification, but fits the theme.
Yeah.
Right. It's always energy.
I'm seeing the pattern. Every mystery explained with energy, like Occam's razor, but for the whole cosmos.
It's intriguing, makes you think, even if you disagree.
Okay, back to Earth for a sec. Chapter 7. Electromagnetism and static electricity fit in perfectly. Everyday stuff. Can the energy idea explain those too?
You bet. Electricity, magnetism. Paper says different sides of energy flow.
Makes sense, kinda. Electricity, flow of electrons, those have energy.
Right, and magnetism, that's from moving electric charges, so energy in motion again. Even static shocks, the doorknob zap. Energy redistributing, paper says, due to charge differences.
So me getting zapped, just tiny energy burst, finding balance.
That's the idea. Reminder that even the boring stuff is still, deep down, the same energy principles shaping the universe. Kind of cool, huh?
Definitely. Okay, next one. I'm ready to get my mind bent again. Chapter 8. Time is just an illusion of energy flow. This sounds wild.
Oh, this is where it gets deep. The paper is really saying time as we experience it, not actually fundamental. It's an illusion created by energy flow.
Wait, so time's not real? All those years stressing about deadlines, meaningless.
Well, not that drastic. The paper's not saying things don't change. Obviously, they do. But the way we experience change, our measurement of it, that's not absolute. It's how energy is flowing, interacting, that creates our sense of time.
So not a river from past to future, but more like the rhythm of the energy dance. Everything's changing at its own pace. That's what we call time.
Great analogy. That's what the paper proposes. What we call time flowing is just how fast energy states are changing. If everything's energy, time's just measuring that speed of change.
Whoa. Makes you think, if we could control energy super precisely, could we mess with time? Time travel, is that even on the table then?
The paper hints at it. Manipulating energy density could affect how time's perceived. Time dilation, that's real, right? Time speeds up, slows down, based on gravity, motion.
So maybe time travel's not impossible, just a tech problem. Figure out the right energy settings?
Physics is still figuring that out. But the paper's point is, rethink our assumptions. Time is not this fixed thing. It's tied to energy, and that's way more flexible than we think.
Okay, down the rabbit hole we go. Chapter 9, The Big Bang Never Ended. I'm sensing this gets cosmic again.
Oh, yeah. The Big Bang, right? The one-time event, boom, universe starts. Everyone pictures that explosion.
Yeah, the ultimate firecracker.
Well, this paper says, nope, still happening. The Big Bang's ongoing.
Hold on, the universe is still exploding. Seems pretty chill here on Earth.
That's where space-time as energy in motion comes back in. We're not in a universe made by the Big Bang. We're in the Big Bang itself, still unfolding.
Brain melting a bit. So, galaxies moving apart, that's not just leftover momentum. It's the Big Bang pushing them still.
That's the paper's interpretation.
Yeah.
Radical, right. But it fits. Everything's energy. Energy's always changing. The Big Bang is that change, just on the biggest scale imaginable.
Okay, universe still exploding, time's an illusion, everything's energy. I'm ready for whatever's next.
Don't worry, there's more. Quantum mechanics, the human brain, even immortality, all coming up.
Bring it on. At this point, my mind's on a roller coaster, no going back.
Oh.
Okay, so we've gone through gravity, black holes, time itself, all energy according to this paper. But where did WE fit in all this cosmic stuff? What about humans?
Good question, right? And chapter 10 goes there. The human brain, the ultimate energy machine, from the universe to us.
Makes sense. The brain's complex. Got to be an energy hog somehow.
It is, but the paper's saying it's more than that. Life, they say, is energy that learned to copy itself. And the brain. That's the peak of how energy gets optimized.
Like all that thinking, deciding, controlling our bodies. Unsurprisingly little power, actually.
Super efficient. The paper even talks about AI here. Like maybe that's the next step. Energy-based intelligence, but even better than us.
Whoa, AI as energy masters. That's a thought. But okay, if everything's energy, what about free will? Are we just along for the ride? No choice.
Big question, and the paper tackles it head on. Even in an energy universe, they say, free will's still possible. We're made of energy, so we get to arrange our little chunk of it. That's making choices, shaping our own destiny in their view.
So not puppets, but like tiny energy sculptors. We get to work with the material.
That's the idea. It's reconciling that energy-driven universe with the fact that we feel like we make choices.
Okay, it makes me feel less like a robot. But now I'm really curious about quantum mechanics, all that weirdness. Can this paper handle that?
Oh, yeah. Chapter 11, Quantum Shenanigans. Yes, it's still just energy, dummies. The ultimate test for the it's all energy idea.
First up, the classic one, wave-particle duality. Lights both, somehow. How does this paper explain that away?
It gets simple. Both wave, particle. Just different modes energy can be in, paper says, like a chameleon changing colors based on where it is. Energy's doing the same, sometimes wave, sometimes particle, depends what it's interacting with.
So not two things at once, but one thing that can ACT two ways.
Exactly. No paradox anymore, just energy being flexible.
Okay, then there's superposition. A particle's in multiple states at once until you measure it. That one always hurts my brain.
Paper's got a fun analogy. An actor trying on costumes, hat, coat, mask, trying combos before picking the final look. Superposition, they say. It's like that. Energy's trying on different states until we measure it.
So it's blurry, all those possibilities at once until we look. And then the act of looking forces it to choose.
Yep. And they emphasize measuring isn't passive, it's an interaction. Energy exchange happens. That's what collapses the superposition, makes it pick one state.
Okay, so we're part of the process, not just watching. What about entanglement then? That spooky action at a distance. Einstein even hated it. Faster than light stuff. How's this paper deal with that?
Remember, the paper's been hinting at it. Maybe what we see as separate particles aren't actually separate deep down, like two ends of the same rope ultimately connected.
Yeah, I remember that.
They use that for entanglement. Those particles, not actually two things, more like two sides of the same energy coin, affect one, the other changes instantly, not because info traveled super fast, but because they were never truly apart, energy-wise.
So not spooky action, but spooky connection. We're just seeing it wrong.
That's the point. Makes you think about separation differently. At the energy level, maybe it's all one big web.
Mind blown again.
Yeah.
What else does the paper cover in the quantum realm?
Well, there's tunneling. That's when a particle goes through a barrier it shouldn't be able to. Paper says, easy. Particles aren't solid little balls. They're energy blobs, can spread out, reconfigure.
So not bouncing off walls, but like oozing through them if the conditions are right.
Exactly. Energy's not stuck in one spot, can get fuzzy, that lets it tunnel. Then there's Heisenberg's uncertainty principle. Can't know both position and momentum perfectly. Paper ties that back to energy being shifty.
So the more you pin down location, the less you know about movement and vice versa. It's like pinning down a wave, impossible.
Exactly. Not our instruments being bad, but energy itself being fundamentally uncertain. At that level, things are blurry, no way around it.
And what about the observer effect? Measuring a quantum thing changes it. Does the paper have an answer for that too?
It does. Measurement, they say, is an interaction. Energy exchange happens, observer to observed. And that's what forces the choice, collapses the wave function, all that.
So we're not just watching, we're nudging the quantum system by looking.
That's a good way to put it. Observation is participation, especially in the quantum world. That's the paper's point.
Okay, I think I'm getting how this energy lens works for quantum stuff. It's oversimplified, sure, but it's kind of elegant too.
Makes you think, even if it's not the whole picture.
All right, ready for the next chapter. This is where it gets really speculative.
Chapter 12, right. Harnessing energy at galactic scale, because why not? It sounds like we're leaving reality behind.
A bit, yeah. This is the paper going full sci-fi.
Yes.
What if we mastered energy, like really mastered it on a huge scale? What could we do?
Let me guess. Control gravity, build those Dyson spheres around stars, maybe even wormholes for travel.
You got it. The paper imagines us as cosmic engineers. Star energy, space-time warping, engineering reality itself.
Cool, but is any of that remotely possible or just fun to think about?
Honestly, it's mostly fun. Physics, as we know it, has limits, but who knows, right? Maybe there are breakthroughs waiting, stuff we can't even conceive of yet.
It's tempting to imagine us as energy masters reshaping the universe, but also kind of scary. What would that power do to us?
That's a whole other deep dive, probably. But yeah, any tech that big, got to think about the consequences.
Okay, last chapter. We're all just energy, so why should we die? This one's got to be philosophical. It is. The paper takes the energy is everything idea and asks, what does that mean for life and death?
So for energy, does that mean death is just changing form? Our energy goes back into the universe, but doesn't disappear?
That's the idea they're exploring. Death, not the ND, but a transition. Kind of comforting, right? But then the question becomes, can we control that transition? Is immortality on the table?
Can we tweak our own energy to not die?
The paper says aging, death. Those are like bugs in how we manage energy. Fix the bugs, and theoretically, we could live forever.
So not that we have to die, but that we haven't figured out the energy trick to keep going.
It's an optimistic view for sure. Imagine tech that lets us control energy flow in our very cells. No more aging if the paper's right.
That's a lot to process.
Yeah.
Even if it's a long shot, it makes you think, is death a problem to solve, not just fate?
Exactly. This paper, even if you don't buy all of it, it makes you ask the big questions. What is life? What is death? If energy is the foundation of it all.
Well, I think we've covered it. This deep dive was a lot. From tiny particles to the whole universe, all seen through this energy lens. Hope our listeners' minds are sufficiently blown.
It's been a trip, that's for sure. Even if it's not the final answer, this paper gets you thinking differently about the universe, and that's always a good thing.
Who knows, right? Maybe someday, thanks to understanding energy better, some of this wild stuff won't be sci-fi anymore. Until then, keep exploring, keep those questions coming. Thanks for joining us on The Deep Dive.